Right. So I think we're at 10 o'clock. So let's go ahead and get started. Ahmad, you want to kick us off? Hopefully everyone can see my slides.
Yeah, it's okay. Ahmed, you are muted. So I request...
I'm mute. Okay, yeah.
So you
I'm
mute.
on mute now. Okay.
Yeah, it's good.
Can you hear me? Yes. Yes, thanks. Thank you, Sean. And thank you all for attending the November episode of our monthly webinar series. The ARMA Technical Committee on Induced Seismicity has these monthly webinar series, as you know. And it's been a very beneficial event for the community, and it helps converge ideas and experiences regarding induced seismicity around the world. And so today, next slide, please. And today we are fortunate to have a presentation from our colleagues in Poland. And let Sean to get into the details of the presentation, but Stan Lasocki, I hope I'm not mispronouncing the names, from Polish Academy of Sciences, and Joanna Kocot will be presenting their work on induced seismicity research related to open access platform for collaborative work in that area. Sean, you probably have some announcements regarding future speakers, and we'll pass it on to you to present.
Thanks, Ahmad. Yeah, so welcome everyone, and yeah, today we're pleased to be able to introduce Stan Lasocki and Joanna Kocot, as Ahmad said, and apologies, Joanna, I know I mispronounced your name again, but Polish Academy of Science that Stan's based with has a long history of working on the topic of induced seismicity. Stan and some of his previous colleagues working in the topic, very well respected in this topic. And the group has been doing some interesting work lately with this episodes effort, looking at developing an open platform for induced seismicity case studies and associated data. So I think an important topic just for general awareness, and we've invited Stan and his colleagues to talk about the work, and both from the perspective of awareness as well as I think I can speak for Stan to say that he's very interested in adding to the data sets that are available. So maybe a potential to connect to some of the participants on the webinar that might have availability of other data sets that could be included. So with that, before we get started with Stan and Joanna, just a few announcements. I'll pass it over to Jens.
Thanks, Sean. It's good to be back, everybody. We have two speakers to announce, one next month and one in a year. Next year in January. Jean-Philippe Avouac from Caltech will be speaking next month, first Friday, the 2nd of December at 10 a.m. Same time, same place. What makes earthquake probability go up and down? What control do we have? And then the beginning of the year, note the date not being the first Friday, but in fact the 13th of January, same time, a project, lifetime approach to the management of induced seismicity risk at carbon storage sites by Denise Templeton from Lawrence Livermore Lab.
Good morning and good afternoon, everyone. Thank you for joining us for another great webinar by Stan and Joanna from Poland. This is Mahdi Haddad from the Bureau of Economic Geology. For better logistics of this webinar series, we have some general guidelines, as you see listed here. So we have a webinar email invitation distribution list. Please let us know if any of your colleagues would like to be added to that distribution list for the following webinars. And we ask everyone to be muted during the talk, but remember, you can post your questions in the chat function at the bottom of the Zoom window. We can summarize your questions at the end of the talk in order to use the time more efficiently. Please also, this meeting is recorded and you can refer to our Induced Seismicity Technical Committee YouTube channel. The link is in the invitation email. Please subscribe to that channel to be reminded about the future uploads. And also, please keep in mind that we are looking for new presenters in the following webinars. If you see any interesting talks, please let us know. Sean, Jens, Ahmed, and me to know about those talks, and we can invite them to present for us. Thank you so much. Without further delay, let's invite Stan and Joanna to start the talk. Thank you.
Thank you very much. Yeah, just I'll share my screen. Okay, I hope that it is visible. And yes, we will come to the presentation mode. Now it is in the presentation mode. So first of all, good morning, Americas, and good afternoon, Europe, because we have some also visitors from Europe. And if there are from any other countries, maybe I should also say or add good evening. But it's just time delays. So first of all, I'd like to say that although we are here from Poland, but we are representing the European consortium of generally a group of people gathered in 8 institutions in Europe, and one is an associate partner from Brazil. But I return to that. And I want to thank for the opportunity to present our efforts in integrating research infrastructure for studies of induced seismicity and generally anthropogenic hazards. Let me acknowledge my co-authors. It is Joanna, you know her now because she's here, and also Beata Olecka-Sikora is she's traveling for after the yesterday meeting, but she helped a lot with this presentation. My name you already know. I am leading this consortium and the group of this European group of European Brazilian group, I should say, of who maintains and develops the program. And also I want to acknowledge the whole EPOS Thematical Service Anthropogenic Hazard group, which I will return to later, and I'll present it later. So, but here, starting from the very beginning, you see the picture taken from the webpage Induced Earthquake.org. It is not ours, but anyway, it shows the severity of induced seismicity problem as well as the geographical extent. And I think that the areas which are not populated with these pins, these are areas which is not much georesource exploitation going, or there is no information about the cases. So, but I want to start from some historical remarks. In 1997, we already talked before about it. In 1997, the late George Gibowicz and myself, we organized and led the Rockburst and Seismicity in Mines Symposium in Kraków. This was 25 years ago. And thanks to the George's very good web contacts, we had a fantastic group of keynote speakers. The Rockburst and Seismicity in Mines is a symposium which repeats usually or on average every 4 years. So this was a very good occasion to meet for the people working with seismicity in mines. But as I said, we had a very good group of diverse group of keynote speakers. Among them, there was a couple, David Simpson, whom we will possibly know, and who is a top specialist in reservoir triggered seismicity, and Ad McGarr. That time he worked mostly with mining induced seismicity. And the same year, but 1 month later, there was an International Association of Physics of the Earth, of Seismology and Physics of the Earth Interior Symposium or Assembly in Thessaloniki. And there was also there within this symposium induced seismicity session, that time convened by Harsh Gupta and mostly dominated by reservoir-induced seismicity. And I remember Dave Simpson, who came there and said something like that he came to Poland, to Kraków, for this rock pressure seismicity and mine symposium to teach us how to use seismic monitoring. And as he said, it turned out that they, means we from the mining seismology, that they used highly sophisticated equipment and processing methods. And then he took this proceedings which we had published in Balkan, and he said that he recommended that to read everybody in the room. And this event, which I described, showed how far the communities in induced seismicity are one from another, how disintegrated the communities is being attached to particular inducing technologies. And from that on, we started to work on the integration programs to group more communities studying induced seismicity from different technologies, but to be more connected to physical things. So later on, that this idea was that we got some support from IASPE, from this International Association of Seismology, and also from other peoples who supported us with the good advices, and also they grouped around us. And so that after some time in 2010, we presented this what was called the World Initiative, but this was only an idea, the vision of how to make research or scientific research in anthropogenic seismicity better. We dreamt about something like to build an international platform of cooperation between scientists in the field of anthropogenic seismicity. This was called TCIS, the shortcut of Teamwork for Hazard Assessment for Induced Seismicity. And basically, we imagined at the time that this could be a group of virtual research centers, which were backed by the newest that time IT solutions. Well, that time this was very novel idea, I think. And each virtual research center should comprise scientists from all over the world, which would have facilities to work together in the same manner as they were working together in one physical place. Then this particular or virtual research center should investigate specified physical problems, particularly those concerning induced seismicity in general, and going, as I said, across their technological origin. And specifically, we wanted to we wanted to provide means to dwell into the idea of relationships between the technological causes and seismic effects, because in the back of this idea was the quite a understandable thought that since the seismic effect, anthropogenic seismicity depends on technological cause, so that changing the technological inducing factors, we can mitigate or generally manage seismic hazard due to anthropogenic seismicity. So this was a general idea, but it was quite clear that if we wanted to have a collaboratory in this sense, grouped in virtual research centers, regardless whether it would be possible or not, but definitely we had to have some infrastructural means for that. together with our European mostly colleagues, we analyzed the problem and we defined what would be needed to as an infrastructure support for our idea of thematic or of TCIS. So what a user would, what the users should have. First of all, they should have a space, which could be, of course, a virtual space, the private space, we call it private workspace, in which a user could organize resources, could upload and download the data or the codes. In the same place, could integrate new resources. At the same time, it would be valuable that the users have access to already pre-prepared anthropogenic seismicity data and applications and tailored codes. Also, this infrastructure should provide capabilities to process the data and to work on the private codes to build workflows composed of the private codes as well as already implemented applications. Also, what we foresee was to have a means to communicate with the community, with the mates, to share private resources in order to work together and to have also the other collaboratory research facilities. And so to get that, we also realized that we should have at least 3 components. First of all, in order to have such an in silico environment, we should have already integrated comprehensive anthropogenic seismicity datasets, and the comprehensiveness is more important than that they are the most recent ones. This is a problem which emerged and which we've been trying to overcome. Let me just explain it. If we want to investigate the relation between technological causes and geophysical results, geophysical effects in the form of anthropogenic seismicity, we must have a technological data. And it is quite clear that the data for the most recent cases are very poorly available. So we defined that for research, we do not need the most recent data, but we need a comprehensive description of the data cases. So the first, as I said, component of such an in silico experiment where there should be data sets. Then the second, we should have some already implemented or prepared bespoke applications which could be used to process the data sets. And also the possibility should be open to add some users code to this whole group. And of course, what the third component must be is if we have data, we have programs, codes, then we must have also the processing capabilities, which we defined as should be a high power computing facilities and the cloud infrastructure. So this was an idea which would be very practically impossible to realize, but we got luck that our ideas coincided in time with the European Plate Observing System program. This was a program which started, I think, from 2008 as an idea, and then in which this was the largest research infrastructure integration program in solid earth science in Europe. Presently, the EPOS, European Plate Observing System, is a multidisciplinary distributed research infrastructure to facilitate the integrated use of data products, facilities from this solid earth science community in Europe, but not only, as will be later said, in Europe. So the topology of this, excuse me, let me take the other, yes, this is laser indicator. Okay, the topology of EPOS is the following. The infrastructure from from different countries, so national infrastructure, are provided or are passed to the domain groups, which are called thematic core services. The thematic core services currently in EPOS, there are 10, and the 11th one is in build. This is a tsunami, not yet ready for integration. But among them, there is an anthropogenic hazard, which we represent here, and we are talking about. And then the EPOS, so the data product services and so on are either are accessible directly from thematic core services, but they can be also assessed through the integrated core service, ICS Central Hub, which provides access to multidisciplinary data coming from the TCIS. And then it is also worth to say that EPOS it is open access according to the FAIR rules, which I think everybody knows, so I don't want to repeat. But among the, as I said, the anthropogenic hazard thematic core service is one of 10 and maybe soon from 11 thematic core services within EPOS. But we are a bit different because our ambition was to build something which would be a laboratory, not only the data provision, not only code provision for the to download, but that would be a space when the user, when the researcher can do any virtual experimentation. So also, and after some time, and I can say that we achieved our goal. Of course, well, like every technical solution, this can be and will be further developed and enhanced. However, now we have Episodes platform, which is just this virtual laboratory. The most important three components, or the broadly speaking, three components of the Episodes platform are the following. First, we have a workspace. The workspace is a place where the user maintains and organizes their data, either uploaded or the data already integrated in a platform. When the user can initiate processing, can do programming, can build workflows, and then when the user initiates processing, then it is delegated either to high power computing or to cloud, as this was already said. Also, workspace gives chance to data and result sharing as well as collaboration. The second component are applications, and this component consists of implemented software tools and private applications of the user. And I want to say only that from where all this stuff comes. This implemented software tools is just codes which are provided by our colleagues, are by scientists who first, this is a prerequisite, published these methods and results in peer-reviewed journals. So then we know that the community, the research community, accepts or agrees with this method, and that this method is of high standard. Then our colleague comes and says, yes, I want to share with you this, I want to share with the community this software. So this is what I'm saying is to tell you that this is a community effort. It is nothing like we are paid for it. We are not selling the product. This is open access, everything. But this is just a community effort. This is an effort of people, of researchers who think that it is better to share their assets rather than to keep them for themselves. The same is with data, although it's more complicated, of course, not a private, it is a rare case that one researcher can come with a whole episode of the data. This is more complicated, but usually the episodes are coming from the scientific projects or so on. So the data within the episodes platform, again, these are either the integrated episodes, and I'll return to that further on, but they are also user uploads. So the user has an opportunity to upload own data and to process them with either already implemented software tools or with private application, or with workforce, or with anything. We wanted, and I think we achieved the goal, to provide to the researcher unconstrained ways to experimentate in virtual way. This is a landing page to our episodes platform, and I will return also to the URL. But what you can see here, it is that we have already 31 worldwide episodes of, as I said, the comprehensive data descriptions of the anthropogenic seismicity cases. We have 70 dedicated services, applications we call them, and we have more than 1,500 professional users. And what is only required, this is absolutely open access, and the access is given to everything. But the only what is required for mainly for statistical purposes, but also for some data providers, they require to know what is going on with the data, who is using them. So what is required is to register and then to log in, and every user who logs into the platform gets the access to private workspace to process the data. Then what is also then the first component, which I said, the episodes, so the data which are already integrated there. There are the sets of time correlated and seismicity data and technological data, which are the cause of the seismicity, and also other relevant geodata. As you can see from the statistics, we actually have practically the data cases from practically all inducing technologies connected with georesources exploitation or exploration. And here we have a map of a geographical distribution of the episodes. Most of the episodes come from Europe, which is clear because this was quite understandable. But we have also episodes from the United States. These are Oklahoma and Cotton Valley and the Geysers. And we have also episodes from Asia, from Uzbekistan, and from Vietnam. And also we have a very interesting episode from Australia. This is the Cooper Basin geothermal experiment. And in every case, let me show it here. This is an opening page for one of the episodes. In such an opening page, in this case, Valdagri field connected with hydrocarbon extraction. It consists of a short description and then the list of the data available, and then the user which can dwell more, going deeper and deeper, and then to send the selected data to the private workspace for processing. What is worth to know is, as I said, this data is open, but we require citation in every case. In every case, these are used. Of course, we cannot force it. We cannot. We only can check whether they've been published or they've been cited or not. But this is in order to give credit to people who make a work to prepare this data for integration. So in this case, as you see, we have the name of the project from which this episode came. Then we have also the how it should be cited and who provided this data. This is the data was provided by INGV from Italy. Then the second component are applications. These are either tailored codes or standard applications to process and analyze data already prepared. So again, everybody can use them freely with either the data, integrated data, or own data within the workspace. That is unlike in the case of the data, which all the data can be downloaded. There is a few applications only to be downloaded because the topology or the construction of the platform is so that it is difficult to prepare application in a standalone mode. Moreover, not all application providers agree to have to leave them for download. So we have three categories of applications: the the one which is used for scientific experimentation is a group of analysis and modeling applications, and this is a prevailing part. We have also the preparatory processing within the group, which is called data handling applications. These are download tools, converter, reconstruction tools, and so on. And we have also the third group, which is called the specialized visualization applications. But please mind that this is only additional applications, because most or all episodes are equipped with the tailored visualization for particular episodes. Within the group of analysis and modeling, we have here is the list what is there. So we have a group of source and shaking parameters estimation. We have a stress field modeling group, exploratory statistical analysis, and a hazard and risk analysis. This is a very under the special care, as we are on anthropogenic seismicity and anthropogenic hazard, or we want to provide a means to study that things. And here we have, again, on this slide, the list of applications is shown. Under this, we see the name, the short description, then we see also who provided this application, who is application to whom it belonged before. And then also we see when one wants to use this application, then it can get in, and then the page for the sub page for particular application opens. When the description is more thorough, there is also information about the possibility, when it was updated, when there are computational characteristics, and so on and so on, which category it belongs. And what is important, the one that, of course, the credit is given to the author, and also we indicate how to cite this. All the applications are on a Creative Commons BY license. And then when a user wants to use this particular applications, this button provides this or sends this application to the private user's workspace. Now the third component is a workspace. This is private user to store and to organize work, to have data, applications, and then the user arranges processing and stores the result. Also the collaboratory functions are pre-prepared, so the user can fully or partially share part of this workspace with other users. And when as I said, when the processing is initiated, then it goes to the high power computing facilities. Here you can see the workspace tree of a private space, workspace space, and here is an example how the process or the results of the processing and how the process can be initiated, processing can be initiated, and the results are coming from one of the applications. Quite recently, we added very important component to the episodes platform, namely the component which allows user to merge own codes or private codes with the implemented applications, or just to process to initiate processing of private codes on high power computing facilities using either the episode data or own data. This is a application workbench which is under this tab, my apps management. And before I will give voice to Joanna, who is an IT specialist, and she's much more knowledgeable than myself regarding this application workbench. I wanted to show you that if any private application is prepared, it appears on a list of applications, but only visible to the owner of this application. So in this case, since I am here, I've been logging here. So then I see my private application among the other application lists. So Joanna, Please. Sorry, the short introduction. Sorry, I mixed that. So we wanted to show how the user can work with his own codes on the Episodes platform and how can change the codes within the Episodes platform after processing. So we prepared a fictitious example based on the following real case of induced seismicity. We know that in many cases, the Gutenberg-Richter model, or better to say the exponential model of magnitude distribution, which is the consequence of Gutenberg-Richter relation, is not applicable. And this is a case also of the magnitude distribution coming from the episode of the gases Prati 9 and Prati 29 cluster. You can see here the magnitude, the observed magnitude distribution. And when we applied the one of the applications which are implemented on the platform, namely the Anderson-Darling test for magnitude distribution, testing whether it is these observations are or can be modeled by exponential distribution, then the rejection was at the P shown here. As I said, this is not a specific case. It is often happening for various reasons. If I have any other chance to have a presentation for you speaking more about the statistical properties of seismicity, then I will dwell in it more. But in such a cases, when we have the rejection with high rejection, so high inconformity of the observed magnitude distribution with the most popular model of coming from Gutenberg relation, then we apply mainly for hazard analysis purposes, we applied a non-parametric kernel estimation of magnitude distribution, which is shown here, and which is absolutely data driven. So it is it requires only to have a data sample represented here by MI, but it is also it depends in some way on the value of the smoothing factor H being here. The smoothing factor is just defines the width of the kernel which is there used. Normally, the H is selected in automatic way, so there is not that you can cheat the data using different H. But in this fictitious example, we assume that the user wants to study how the probability density will look like. Probability density of magnitude from this particular episodes when he changes or she changes the H value, the kernel or bandwidth value. Okay, so now Joanna, the floor is yours.
Okay, thanks for this introduction. So as Stan told you, we have a possibility to include your own codes within the Episodes platform to be used with the data and applications of the platform itself. So in this way, you can create workflows that combine both the built-in platform features and the ones you developed for your own. So you have the data, the analysis tools. Stan just show you one of them. The storage and the provenance the platform gives you, but with the flexibility that comes from using your own programs. To include this functionality in the Episodes platform, we used the Git, which is the version control system. This is the standard tool for keeping the application codes, for versioning, for collaboration. So it might look familiar to you on the slides on the movie. And for the sake of this demonstration here, we assume that what Stan explained, that the user wants to study the impact of the kernel width on the non-parametric magnitude estimate. So this is a MATLAB function that does this. We have the smoothing factor or the H here as a parameter. We also have the completeness magnitude, which has to be given to for the calculation, and the catalog. And we return the magnitudes and the probability density values for it as the return values. These are MATLAB vectors. Yeah, start. So as you can see here, the user can work now on his private computer with the environment or program of their choice. This might be MATLAB, this might be Octave, as I have, and then synchronize this with the online repository that is connected to the platform. So this, you can see here, are the codes, the same codes as they were on the private computer. And once they are online, they can be they are visible, and they can be used as any other application that is built in the platform. So you can see here that I can search for it and find it, and the only thing that distinguishes it is this blue label that tells you that this is your private and nobody else has access to it, unless you want to, because this is also possible to share it. So now we can add this application to make the actual computation. And as we wanted to investigate the magnitudes in the episodes, we choose the catalog. It was before downloaded from one of the episodes. We have to give the parameters that were in the function. So the completeness magnitude, I take from the application that was run on the same catalog, but this is a built-in application that computes this estimation. And I take one of the values just to use the application that was built in, the smoothing factor. And after running, we have these two vectors, magnitudes and probability density. But now we might want to add some visualization, and this will be done now. So this time I am acting online. I am editing as a user, of course. I am editing the one of the scripts just to add the plotting here. So these two lines entered just plot the two vectors and save them as a PNG file. And now I am saving this script with a comment, and this comment would allow you later to see the history of the editing of the file. So thanks to this Git version control system, everything is versioned, and you can see this on as a modification within the script. And then you can check the history, how the file was modified, and then of course revert and so on. So once we have this modification made, we reload this version from the repository as this was changed there, and again run it in the workspace. So now instead of the two vectors, we should have one more file, which is this PNG plot. Yeah, and from the plot, we can see the nonlinear structure of the magnitude density. And of course, we can change again the parameter and run the application again, change the script and so on to make the analysis we want.
Thank you. Thank you, Joanna. Well, I realized that I promised to be very in 45 minutes, and it is already 45 minutes, so I will not continue too much. I'll skip some slides. Only to say this is to show that we have users. It is more. I showed before that it's more than 1,500, and the most of users coming from Europe, but there are also users from other parts of the world, including I think all parts except Antarctica. But it is what matters for us. The most important users are researchers, because this is integrated infrastructure for research. So, and we are very proud to have many citations. This is currently we do not trace very well. So what we know, it is more than 60 publications in JCR journals which cite the use of the episodes platform. Some examples are here. And also, we also published information about the platform in other journals. So these three are about the platform itself. The one was in Scientific Data in 2020, and the next one is here shown. It is the most recent because it's from this year. But I want also to add that although this is a geophysical or anthropogenic seismicity virtual laboratory, but behind it, it is a very leading edge solutions in IT prepared by our IT team, IT colleagues led by Joanna. And they also published a paper based on their experiences with building Episodes platform. They published in this year in Future Generation Computer Systems. So Episodes is also suited for scientific collaboration, and it is present in many different projects. Here I show only the use of the platform in Horizon 2030 and Horizon European projects, but they are also used in national projects. And most of the data come there back to NASA. When it is used the platform is used as some place when the collaborative work within the projects can be done, and some data are integrated in. Then they construct new episodes. But in addition to the research users, which are the main, the principal users, or should be the principal users, Episodes platform is also a very good tool for education and for spreading knowledge about seismic hazard, anthropogenic seismic hazard among the public. So here you see pictures from a few examples, which we, among others, we had the use of the platform, workshop of the platform for education purposes, and so on. Okay, then just to coming to the end, there's some words about us. As I said, we are the team mostly from Europe, the team of scientists and engineers. The consortium at Epistematic Consortium Anthropogenic Hazard consists of 15 institutions from 8 European countries and from Brazil. And well, we are, as I said, this is a community effort. So we are not, this is not a formal project. We are providing everything. Why? First of all, we prepare something which we think it is valuable and can be used to make a better science within our discipline. So what we dream for, or what we wish to have, is to have more users. Because if you did something for people, so we wish people to use it. Then, of course, it will be fantastic if somebody comes to us and says, okay, I published this method, I published these results, but I have this code and I want to share with other people. So such a share leading edge methods will certainly find place in a platform. The same with episodes. Of course, we have now 41 episodes, but as everybody wants to have more in order to give more space or better variety among the cases for research. And of course, it will be fantastic if we have any deeper links with other organizations, other institutions. And I think that this seminar and the fact that you invited us, it opens also the collaboration between us, if you wished, between us and your committee within ARMA. And here the two final slides. I think this presentation will be available. These are links. First, the most important, the links to the Episodes platform. Then there is some promotional materials and the papers about the episode, about us and the Episodes platform. And that's everything for today. And thank you very much for your attention.
Great. Well, thanks, Dan and Joanna, for the interesting presentation. And so we'll go through some questions. There's a few questions on chat, but maybe I'll ask a first question, give people an opportunity to put things on chat as I think of it. So first of all, I think there's a great initiative. I think a number of people on the call were part of a workshop, for instance, that we held in Austin in June, the SEGSP workshop series. And something that came out very clear from that, and it's really repeating what's come out clearly from other similar discussions previously, is researchers wanting more open access to data sets. So having complete comprehensive data set availability like this, I think is great, and particularly having a robust supported platform to host it on. I guess the question I was going to ask out of curiosity, certainly a hot topic in the area of induced seismicity is the application, the risk associated with CCS carbon storage. I saw on your list, Stan, you have one example currently of, can you give a little bit of insight in terms of the carbon storage example you have?
We have one example. This is from Iceland. This is a mixture of geothermal and then the CCS. Of course, well, we wish to have more, but it is as I presented, as you know, it is not so. The CCS is a hot topic, and it is it is studied thoroughly. I think that I hope that we'll have more, but we have this one. It is from Carbfix from Iceland.
Great.
Let me also add, because I missed that in every case, for every episode, we have a signed supplier letter allowing us to redistribute the data. It is not that we are taking the data and putting them somewhere, but this is square. This is tightened up completely. I mean, we have a right to use the data wherever we present it on a platform.
Great. Thanks for that clarity. So Colin Sayers has a question. I think the very first slide you showed was a global map of induced seismicity cases. He was asking just a color coding the identification of the different causes. I think Jens posted a capture of the solution, but I think that addresses the question. But Stan, just to pose it to you in case you wanted to clarify more.
Actually, this is. Let me show that maybe. Okay, it is. Yeah. How is? Close it, that one. No, but I have to share the screen. Okay, it's here. Yes. This is not ours. I mean, this was only to give a background for our motivation. This is not our map. This is map taken from the web page, which shows the examples, or it gives the information about the possible source of the data all over the world. And it is led by our British colleagues and I don't know. Yeah, this is the human induced earthquake database, and the particular colors are connected with particular inducing technologies. I'm not able to say. Maybe we'll find it here, but I'm not able to say which one. Yeah, this is a name of but the name of the mining is red, and what is there? Fracking is yellow, and also water reservoir is blue. So I read it right now, but it is very interesting web, and I recommend everybody to go there. The address is given here. As I said, this is not our map, but it is taken from there. And I think that you'll have this is a very complete information about the cases, also with the most the largest events there.
Great.
But it is a bit different. We are linked with them, but it's a bit different because they do not provide data, they provide information about the cases.
Excellent. I think that's how Jens found went to the site to get the key that he posted. Not to steal your secret there, Jens. So a couple questions from Ryan Schultz, maybe go through them, go through the list kind of sequentially here. But so first of all, Ryan was asking, he was curious how the database would be updated. So if there's ongoing injection for a particular site, how do you treat updates to the data? And I guess how fresh is the data?
In most of the episodes we call them closed. I mean, these are past data, these are past cases. But the reason I revealed before, we are unable to get technological data from the most recent of the ongoing cases. It is and also to get license to disseminate this data. So most of the cases are already done. Like for instance, the Cooper Basin, it was an experiment. They finished the experiment, and then we have information about the injection rates and the wellhead pressures and the seismicity. In few cases, on few instances, we have we call them live episodes. And we update as soon as we get the data from the data provider, because we do not. Well, there are also two cases when my institute records or monitors seismicity. But even in such a cases, we must get information from the technological information from the company. So then in such a cases, we put them immediately after we get license to disseminate. But it is usually, in the best cases, it lasts half a year. So it is not the recent information. This is not the information let's say, place. It is just to do whatever you wish and to process and to make research.
Great. So Jens had a question, but maybe we can come back to Jens's question after the end of kind of the formal period. But I think we only have a couple minutes left. But Ryan asked a follow-up question. I think it's particularly pertinent to the group here. So maybe we can conclude with a quick response to Ryan, and then we could maybe continue the discussion more informally afterwards. But Ryan's question is a good one. He's curious how people would contribute to the platform if they wanted to. And I guess that's both data as well as potentially tools.
The question, how could people contribute to that?
Yeah, who's the point of contact, and
normally, as I said, this is a community effort. So if this is a voluntary commitments, but it will be naive to think that the harmonization of data harmonization and the reformatting and of the multidisciplinary data, because we have, as I said, from different sources, it is a process which does not require much manpower. So it is yes. It is based on voluntary work, but it is to some extent supported, at least from our side, from the side of the maintenance. It is supported partially by European money and partially by national money. At least the secondment for manpower. So within the consortium, which, as I said, consists of 15 institutions, the management of institutions agreed that some work will be done by the employees to this program. But of course, the most, if somebody comes with a product, and this product is considered to be valuable, And as I said, we are unable to discriminate, but we judge over the publication. So then he or she providing the code has to cooperate for some time, but usually it is on voluntary basis. I mean, from our end, we are, since we do many such things, so we have some support either from our institutions or from European money. But people who, it's often happening that they come and they offer us something. For instance, maybe you remember when you were here, Andreas Wistfeld said that he could arrange for us Cotton Valley episode, and this is a lot of the data. And he just provided this to us, and we worked on that I think, longer time because the data were not in a very good way. They had to be reconstructed to be prepared for integration, and we did it. But this was absolutely voluntarily based from Andreas.
Great. Well, thanks for that. And yeah, it's a good example of that Cotton Valley experiment of having it's great to have a place, a repository to point people to. And Stan, I guess the question of the point of contact, you would be a good point of contact yourself, and you could, if someone's interested, presumably connect them up if there's someone more appropriate. But we've reached the end of the hour period. So I guess on behalf of ARMA and the Induced Seismicity Technical Committee, I'd like to thank Stan and Joanna for the presentation, and thank all the participants for joining the webinar. We certainly appreciate the support we've seen. And just a reminder to everyone that the next webinar will be December 2nd. Professor Avivak from Caltech, be again a very interesting presentation, I'm sure. And if anybody has additional questions, I think Stan and Joanna have agreed to continue the discussion afterwards, so we'll continue question more informally. But thank you, everyone.
Thank you.
Thank you.
Thank you, Stan and Joanna.
Yo.
Thanks.
Just to answer, I see I haven't finished the answer to Ryan. It is the best point to contact is of course me, and my email is there. And if you'd like to contact me, then we will respond, or either me or somebody from my team, or in case of IT, of course, Joanna. And whoever is contacted, the answer, the reply, the response will be immediate. So please don't hesitate. We will be happy to have something more, some next contributions.
Ryan, feel free to unmute if you want to.
Yeah, I just wanted to say the one thing here before I go, which was thanks for doing this. Essentially, this has been I've used the platform already to look up cases of induced. It's very convenient to have all of this data in one place where you can start doing big comparison studies instead of having to contact every single author and hope that they still have their data hiding around somewhere. But so yeah, thank you.
Hey Ryan, I thought you were going to offer up some tools to go on.
I was just curious, maybe in the future for specifically data sets or something like that. But yeah.
But what we really dream for is that it is not treated as a data repository. I mean, it is not that we gather data to be downloaded, but we rather wish to go towards the processing done with us, with the full capabilities of the high-power computing which we have. So this is actually the part which Joanna showed is the most important part, because it was to show in which way I can take my code done in MATLAB or in Python, and then I can put it on a platform. I can change it there, and I can process the data there using our computing facilities.
Jens, we didn't get to your question, do you? It's a good one.
Okay, yeah, I was actually going to say maybe we could skip that and I could ask a different one, because you're saying you don't want it to be a repository. But just quickly, I was wondering if you this is very similar to Ryan's first question. In cases like Oklahoma, where the human-induced earthquake catalog is a little out of date about cases of induced seismicity, where we expect the vast majority of those earthquakes to probably be induced by one form of industrial activities or another. But it's very hard to say this earthquake was caused decisively by, especially if it's wastewater disposal. Is there a strategy for how you handle situations like that? Or is that kind of outside of your focus because you're not intending to be a data repository?
I will say that actually this is also a bit out of our possibility, because look, we have the episodes are coming from the completely different, let's say, physical spaces, like Oklahoma case, and for instance mining case and so on. So we are unable to be responsible for the let's say logic of the case. So we believe that if somebody says this is a complete episode, it is, in case of Oklahoma, it is not that we have we have a well distribution, we have information about the injection process which took place, and we have a general distribution over a larger area of the earthquakes. This is completely different than in, for instance, the Prati 929 cluster, which is only 2 wells, and it's clearly seen that the seismicity was connected, was initiated, was induced by the injection within these 2 wells. So, but it was brought by different people. The first one we obtained from within the shear project directly. Yes, after they use platform within the project. And then the second case, this was provided by GFZ people who worked on this case of the Prati 929. So this, as I again, please understand that we are not ruling that. We are only coordinating the work. We are not ruling. We are not governing. We are coordinating to have it already there. And if for somebody, we believe that the knowledge comes with the data, that somebody wants to add them because things that they are valuable.
I can ask my other question later, so other people have a chance to ask. No.
Yeah, so please, if anybody has any questions, feel free to unmute yourself and take the opportunity.
I have a follow-up question. So for instance, I see fracking is #1 in the first map that you showed, but that is at the same place that wastewater disposal is happening. So, there is always overlap of the strata where they do fracking and waste fluid disposal. They tend not to transport the disposal fluid to another location. So they find a higher permeability zone and they inject it right there. So it's really hard to distinguish between this. It needs some mechanistic model to develop these different mechanisms for the earthquake.
That's absolutely right. It is. The categories are not definite, and these are only shown to and they overlap. The data overlap. For instance, in the case of Oklahoma, we have wastewater injection and fracking, and this category has been introduced to help people to select the data and also to attract users. But it is in some cases, it is difficult to distinguish. In case of hydrofracturing in Europe, where wastewater reinjection was banned, so it was clearly that it was due to hydrofracturing. But in the case of, for the United States cases, it is not. But we think that afterwards, after the user is attracted and comes there, that the user is very knowledgeable. I mean, knows what wants to and what's the situation. We provide also references to the papers about these cases.
Mhm.
And then this is I didn't mention about it, but we have a document repository and also references. So if somebody starts dwelling in the case, should read something about it, cannot go on blindly.
Mhm.
So this is actually our approach. We believe that the users are mostly people, mostly researchers. That this is not, to provide information how the yes, we say it. We can provide, and we say frequently to our industrial colleagues that we can increase the level of resilience of the societies. So the level of acceptance of particular inducing seismicity technologies. But we do not think that somebody will come and learn from the platform what happened, even you want to avoid it, because this is, as you know, this is a very social, delicate problem. The social response to technologies which induce seismicity.
Right. Thank you.
Well, Stan, if you could identify how to solve it, I think your number of users would go through the roof. So I think he's off. Andreas Gibson was asking really just the source of that initial map, but is that Julian Folger's efforts, the induced seismicity database? I guess I haven't looked myself in a while.
Well,
Yeah, I think that's right. Or at least she's one of the leader, I think, or at least used to be.
yeah.
Excellent. Well, I was impressed with your long list of colleagues and collaborators on the project at the end, Stan. I think one of which is, I see Jan Seleni's on the call here. So Jan's been...
He's today with us.
Oh.
I see him on the list of attendees.
Yeah.
Hi.
I think he's called in. It's good to see. I think we with your webinar, I think we had more European attendees than we typically do for this particular event. So it's great to see.
Definitely, yeah. I try to spread it, to promote the webinars, because it is it's a good chance to get some new ideas. So it is in addition to the fact that we had chance to present ourselves, but we are very happy that we can take part, we can attend your webinars.
If I could ask my other question, unless somebody wants to jump in first, I guess I can't really resist asking about stress. You mentioned stress modeling and things. I'm very curious what you have in mind, and whether you're interacting with the World Stress Map people on that, because I know they're kind of expanding their capabilities about the style of faulting and so on. And the context is partly that it's often the case that focal mechanism stress inversions can be challenging and have maybe more uncertainty than one would even quantify in them, and so I guess it's kind of a challenging problem, and I'm curious what you have in mind.
Regarding a stress modeling, would you have there?
Yeah, is it stress modeling, stress mapping? I'm just interested in what you're up to.
Yeah, this is stress inversion. It is okay. Yeah. This is MSATSI. It is a MSATSI work package will be done. It is Patricia Martinez Garson, GFZ General. You know it, I hope. Mm-hmm. So this is unfortunately we don't have many. I mean, this is also what I should have said before, that I think that whereas we have good data and processing tools from seismology, we don't have many from rock mechanics. And the other is from Thomas Fischer from Institute of Geophysics, Czech Academy of Sciences. This is the effective stress drop estimate. But if you are more interested, please visit the platform and you will see I think there are two only. Yes. Yeah, stress field modeling. There are this is the general category. But this
Well,
is not. There are unfortunately only two.
Yeah, no, it's really interesting. I meant to say first that this is an amazing platform, and I hope that we can use it more in the US. And part of the reason I was asking about Oklahoma, I think, is that you could imagine making use of the huge catalog, earthquake catalogs for covering such a large region there, and you could probably do really a lot with that using this type of platform. So I hope that happens.
Yeah, definitely. As I said, we are. Our problem also is that after a time, the episodes which we integrated will be exploited. I mean, we have to renew the databases if we want to provide the data for research, because after some time, how many publications can be done on one case? Of course, they can be many, but there is a limit. So in this way, yes, we are thinking of new episodes, of renewing the database, and of course for instance, also of enhancing the particular components like TCIS. Although there are no many severe TCIS anthropogenic seismicity cases, so it is much easier to find from geothermal or from mining when we have magnitudes 4 happening every 2 years, at least in Poland it is. So it is. So it's. But we are not going to have a record. We are going to have a variety of cases.
Thanks.
Well, it's great to see the breadth of examples for sure, but I think Jens raises a really good point with the world stress map and Jens's work looking at mapping stress through North America. Jens with Professor Zobak. Well-known work, at least to those of us in North America in that space. So it seems like a good linkage to the episode.
Yeah, it will be fantastic. Yes, definitely. Yeah, super.
Any other questions for Stan before we let him go, and then Stan and Joanna can enjoy their Friday evening in Krakow?
Yeah, now we can. Yeah, we are closing the week, so.
Yeah, same here. We're just earlier in the day on Friday here, but Stan, thanks for doing this, and maybe inconvenient time of the day for you guys being end of the day, but we certainly appreciate your.
Yeah, thank you very much again for invitation, and I hope that we will be able to develop some contacts between this. It don't have to be formalized, but just to interesting for both sides. Yeah, definitely we will attend your webinars as long as you send us the information about it. So thank you very much for everybody. Thanks to all for our attendees, even though not everyone are here. And yes, we are very grateful for giving us an opportunity to present our work.
I see Marty's got you on the distribution list, so you'll be receiving. You and your colleagues will be receiving the invitations going forward. So yeah, right. Well, have a good day, and it's great seeing you again, Stan. Nice to meet you, Joanna. Thank you for your efforts.
Thank you.
Thank you.
And bye.
Bye.
Thank you.
Bye, everyone.
Thank you so much.
Thank you.
Have a good weekend, everyone. Bye-bye.